So today we're going to spend a little time looking at something called double angle formulas. I may briefly touch on the concept of a half angle formula. It's not in the front cover of your book, and it's worth looking at because it's a little bit unique. There's also several other formulas in this section. I am not going to spend time on them. You usually won't need them unless you take a class of Calc 2 or higher. And I know several of you are looking and going, that's not going to be me. Some of you will take it, but when you do end up taking it, the formula will be rather self-evident to you at that point in time. And so I'm not going to spend a lot of time on it. So the double angle formula, though, I'm hoping it's also fairly self-evident, but there's some details that I want us to look into. So we want to go back, actually, and consider the angle sum formulas that we had earlier. So for instance, if I had the sine of alpha plus beta, what did we find is the expansion of the sine of alpha plus beta? Kind of nice when I can give myself a little more space. Unfortunately, you guys can't do that on your papers. It worked. Okay, yes, that's correct. That's the sine of alpha plus beta. So mathematicians will look at things like this and say, that's kind of nice, it's an interesting formula, but what happens if I decide I'm going to take the sine of alpha plus alpha? What does that then look like? Now, being mathematicians, does it make a difference if it's the cosine of alpha times the sine of alpha or the sine of alpha times the cosine of alpha? Does that order of product make a difference in the final result? Okay. Well, by the way, what's alpha plus alpha?
2 alpha.
So that means I could rewrite this saying sine of 2 times alpha is equal to, and then I've got this statement plus this statement, and you told me that cosine of alpha, sine alpha is basically the same thing as sine alpha, cosine alpha. So could I condense this side down too? And say that is 2 times the sine of alpha, cosine of alpha. Are those equivalents? Okay. Here's the good news. That's your double angle formula for the sine. So in other words, if you have the twice of some angle, then you have 2 times the sine times the cosine of the original angle. You're saying, well, that's kind of nice, so how do I use that? What does it mean? Right? All right, so let's look at an example of what this does. Suppose we have a triangle. And not only do we have a triangle, suppose it's a right triangle. That angle's alpha. That side is 24 inches. And this side is 25 inches. What we would like to do is we would like to find the sine value of 2 times alpha. Or whatever that angle alpha is. This is one of those things that tends sometimes to show up in an engineering question or an architecture question. You're building something, you're designing something. Think about what happens to twice the angle. Because once I begin to think about twice the angle, then I can start talking about forces on the object or stresses in the object or things like that. And when I change the angle, it does some different things. So we want to know what is 2 alpha. Well, according to what we just showed, 2 alpha, or the sine of 2 alpha, is equal to what?
2 sine alpha.
So here's my question. Can I write a relationship right now for the sine of alpha, which is on this triangle? Just as it's written. Can I write that relationship? Well, the sine of an angle is what side of the triangle over what side of the triangle? So when I think about the opposite side, don't know that. Hypotenuse I do know. Could I write a value for the cosine of alpha? What's the cosine of alpha? What's the adjacent side length? What's the hypotenuse? Alright, so what else do we need to do to find the sine of alpha? Sure. Using the Pythagorean theorem, please tell me, what do you think is this number over here? You either know that because it's a Pythagorean triple, or you very quickly take 24 squared away from 25 squared, and then the square root of that 49 that's produced. Something like that. So do we have every number value here that we need? Okay. So what is 2 times 7 times 24 divided by 25 divided by 25? Making something sort of like that. 328 over 625.
Actually,
No, you didn't.
I got decimal.
You should not have gotten the decimal.
I got 333.
Yes, you did. Please don't believe everything I write.
Well, shoot.
Please do the math.
You got us, Mr. Rich.
Maybe.
April Fool.
No. I say you need to do this operationally. That looks much better. Right. Now do we agree with that result?
Yep.
Okay. Somebody said that's a decimal, right?
Yeah.
What is that decimal?
0.5376.
0.5376, okay? Is there a way to find the measure of the angle alpha?
Yeah.
How could I find the measure of the angle alpha?
Arc sine, arc cosine, arc tangent.
Which one?
Well, we have all of them.
Should this use cosine and that's the number d first?
Probably not a bad idea. Let's use the arc cosine of alpha. If you use the arc cosine of alpha being 24 over 25, please tell me what is in degrees, because this is a right triangle, the measure of angle alpha.
16.2602471 degrees.
So you said 16.26. So what is the measure of angle 2 alpha?
32.5.
You got an answer? 32 point what?
52.
32.52. Can you take the sine of 32.52 degrees?
Yes.
And do you get the value that's pretty close to what we found with our fraction?
Yeah.
Is it an exact match or close enough to make an exact match?
Close enough.
Huh? Has a few more numbers. Well, I'm sure it probably does. Is it going to be close enough for us to work with if we were dealing with significant digits?
Yeah.
Probably. All right? So it works out. It's a different way of doing some things. Understand that a lot of the math that we developed in this era was done in the absence of a calculator. We didn't have those devices to do all this arithmetic for us. And so the task of finding the 16.26 degrees was very steep in terms of finding values, especially if we realized we didn't need that number. We had a way to go already. That's where some of this thing developed from. There are some other things that are helpful here. There will be a few times where knowing this relationship to here will provide some assistance for us in a calculus class or other places. Just be aware of that.
Wait, how did we find that 16.26 again?
We did the arc cosine of 24 over 25, which is going to give me the angle answer. All right. Any other questions about that?